Hello and welcome to this video. We're going to talk about shell in ethical hacking. So we're going to cover what shells are, the two main types you will encounter, and why one pattern is usually preferred during remote access. So this is going to set the foundation before we look at the exploitation framework, which we're going to use later. What is a shell? A shell is essentially the remote access channel into a compromised host. This is a remote access because it involves the attacker at one end and the target at another receiving end. So once deployed, it lets us run commands and interact with that system. So once a shell is deployed, it enables the attacker run commands and interact with the target system. Think of it as an interface that turns a successful exploit into real control. Shell is equals to payload that gives access. Practically speaking, a shell is the payload we drop after exploiting a vulnerability. It provides the attack with command level control and becomes the bridge for further action on the target machine. So let's look at payload delivery. Deployed after successful exploitation. That means that payload is deployed after a successful exploitation. Then the command control enables command level access to the target system. Then bridge for actions, gateway for further operations on the machine. Let's talk about the two common shell patterns. There are two typical approaches used to establish shell. We have the reverse shell and bind or bind back shell. Each follows a different connection model and has distinct networking implications. Now, the reverse shell, target calls back to you. That is the reverse shell. With a reverse shell, the compromised host initiates the connection to your machine, that is the attacker's machine. Your system waits, listens for that incoming connection, and when the target connects back, you gain an interactive section. This is often the more practical method in real world scenario. Imagine you pick up your phone, you call someone at the other end, then you wait until the person says hello. Once the person says hello, that means you have established a connection back from the receiver to the attacker. Let's look at connection flow. Target machine is compromised. Target initiates outbound connection. Then the attacker's machine listens for connection, and thereafter interactive session is established, meaning there's a connection between the attacker and the victim or the target. And this connection enables the attacker to run commands on the victims or the target machine and access information. Now, key advantage: more practical in real world scenarios because outbound connections are typically allowed by firewalls and network policies. So here it says that firewalls allow this kind of connection. Okay, let's look at bind shell. You connect to the target, that is the attacker connection to the target. Now, a bind shell flips that model. The target opens a port and listens for incoming connections, and you connect directly to that port. Conceptually simple, but it relies on the target being able to accept inbound connection on an exposed port. Here is the bind shell connection flow. Target machine is compromised. Target opens listening port. The attacker connects to that port, and there is an interactive session and it is established. Key requirement: relies on target being able to accept inbound connection on an exposed port, which is often restricted. So now you have seen that we have bind shell and reverse shell. These are the two kinds of shell we'll be talking about in this section. Now, why bind shell often fail in practice? Many environments block unexpected inbound ports. for security reasons. And firewall or network policy commonly prevent random ports from being opened on a host. So even if you exploit the machine, the bind approach can be blocked before you can connect. Under firewall restrictions, unexpected inbound ports are commonly blocked by security policies. Network policies, organizations prevent random ports from being opened on hosts. Then practical failure. Even after successful exploitation, bind approach can be blocked before the connection, while reverse shells are usually more reliable. Reverse shells work because outbound connections are typically permitted. It's similar to how a user browser connects to websites. Since the target is the one initiating the outbound connection, it usually bypasses the restrictions that prevent you from connecting to an open port on the target. Outbound connections mirror normal web traffic behavior, making them far less likely to be blocked by security infrastructures. So what we are saying here is that the bind shell is not as reliable as the reverse shell. So we're going to be seeing an example of reverse shell as we continue in this section. Practical takeaway: prefer reversed when possible. When given a choice between the two shell, use the callback style, which is the reverse shell. It avoids many firewall and NAT problems and mirror normal web traffic behavior. That being said, understanding both patterns help you adapt to different network setup. So there is need for you to learn about both of them, despite the fact that reverse shell is better. Number one here, use reverse shell by default. Callback style shells avoid firewall and NAT complications. Mirror normal traffic. Reverse shells behave like standard web traffic, reducing detection risk. And number three, understand both patterns. Knowledge of both approaches enable adaptation to different network environments. So it's good to know how both works so that you can take decision on any environment you find yourself, to know which is going to be useful at that particular time. So next, I'm going to be introducing to the exploitation framework proper. So now that we have understood the shells, we will introduce the exploitation framework, the primary tool we will use to identify, exploit, and manage access on targets. It acts like a map of technique and modules, and we will start by learning its basic before trying any hands-on practice. For underlearn framework basics, understand the structure and organization of techniques and modules, explore available tools, discover the capabilities and resources with the framework, then prepare for hands-on practice, build foundation before attempting practical exploitation exercises. So that is all for shell. So at the end of this video, it is clear now that you understand the two types of shell we have and why the reverse shell is more reliable than the bind shell. That's all for this video, and I'll see you on the next one.